This is question 30 from the LO3 tutorial questions for engineering dynamics. Here we have a question where we've been given the thickness of a uniform disk and its radius, and also the density as well. So this should tell us that we're going to be using our formula for density, which involves mass and volume. Now, we don't have the information in the question to get the mass. We need to find that from that formula, but we can work out the volume of the disk. And once we have its mass, we can work out the moment of inertia. So let's have a look at what we've been told. We're told that thickness 1 centimeter, radius 40 centimeters. Well, a disk is like a cylinder with a very shallow height. So the formula for the volume of a cylinder is V equals pi r squared. That's the area of the circular side times the height of the cylinder, or in this case, the thickness of our disk. So what information do we have here? We're told that our thickness, which will be our H value here, is 1 centimeter, which is the same as 0.01 meters. Remember, always work in meters in these questions. And the radius is 40 centimeters, or 0.4 meters. So we can put these into our formula for the volume. We get pi times 0.4 squared times 0.1. And working that out in our calculator gives us a volume of 5.027 times 10 to the minus 3 meters cubed. So a small number, but we're working in meters cubed, and that's going to help us with the rest of this question. We can then work out the mass of the disk from its volume multiplied by its density, which we're given in the question. So mass equals rho, that's the symbol for density, times volume, is equal to 7850, because we're given this in the question up here. And that's kilograms per meter cubed. So multiplying it by a volume in meters cubed, and that's what we got in the first part, will give us an answer in kilograms. So I'm just taking that value of the first question in my calculator and multiplied it by 7850. And the answer I get for the mass is 39.458 kilograms. You may have a slightly different answer if you're not using the full calculator value from the first part, and that's okay. Lastly, we need to work out the moment of inertia. In this question, we have the radius of the whole disk. This isn't the radius of gyration, so our formula is mass times radius squared divided by 2. This is the formula we use when we're working with a solid disk and we know its radius. And we can put in our values. So here's a value for mass we just worked out there, multiplied by our radius, which was 0.4 squared divided by 2. And using our calculator, we get the answer 3.157 kilogram meters squared. Again, I'm using exact calculator value for M. So you may have something slightly different that's in that region, then you're correct. And that's the answer to the question there.